Yes, please listen carefully. So, first we will discuss what this stream cipher is and what is this block cipher is. So stream cipher, here when we encrypt, the message is going to be processed bit by bit. Okay, like already we have studied about the XOR operation, how the XOR operation helps in encryption. You would have even done the experiments in your lab. like so the plain text that is given, it would be either processed bit by byte or byte by byte. Okay, so it is processed in a bit by bit manner. So here you can see in the diagram, so we'll be having a plain text and we'll have a key. So this key could be generated by the pseudo random generator that we have already discussed. So based on the key and the plain text, it encrypts using the XOR operation and it will give you the cipher text. Okay, so similarly the decryption also happens in the same way. So both of them happens using bit by bit, or we can call it as stream cipher. And the another type of cipher is the block cipher. Okay, so in block cipher, here we have the plain text. It is going to be it is going to be taken as a fixed length block. Okay, so each block, so the plain text that you take, it is going to be divided into blocks, and each block will be of size b bits. Okay, it will be of size some b bits, and the and we will take a key as a input. And now this this encryption model, it will produce the cipher text, which is also of the same b bit blocks. Okay, so that will also produce the blocks of text, which will also be each having b bits in size. As you are dividing the plain text into blocks, so each of the block is of length b bits. Okay, either it may be some 64 bits or 128 bits or something like that. Okay, so as you are dividing like that, if the last block, if it is not having that much bits, okay, if it is not 64 bits, then you can pad the remaining thing with some other bits. Okay, so padding can be done in the last block to make it as b bits, so that everything will be uniform. Okay, now in this there are different modes of operations we are going to study. So as we are going to encrypt these blocks of plain text, if we are going to use the same key, okay, if you are going to use the same key, then that may produce several security issues. Okay, in the there are different modes of operations has been defined by this NIST. Okay, this is the National Institute of Statistics and Technology. So where they have bring out five modes of operation, but in that we are going to study only the three modes of operations. Okay, so that is given in our syllabus, and we'll be studying about the three modes of operation, how this encryption and decryption works. So this is the block cipher. So the plain text, it will be taken as a block. Okay, each block consisting of b bits, and the key is applied. So the cipher text will also be of the same b bits in size. And similarly, the decryption algorithm, it takes the cipher text with the as a block and produces plain text in blocks. So now we will be studying about the various block cipher modes. What is this mode of operation is that either it will enhance the effect of the cryptographic algorithm. So basically the cryptographic algorithm itself we are using for the security purpose. Okay, so whatever the message that you are transmitting, it should be reaching the concerned person securely. Okay, so so we, to enhance the security, we need to enhance the cryptographic algorithm that we are using. So now this algorithms can be used for any application where we want our message to be communicated um, safely and securely. So now this block cipher, most of the encryption algorithms uses this block cipher to encrypt the messages. Okay, so there are five modes of operation. The first one is electronic codebook mode. Okay, we can in short we can call it as ECB. And then the second one is cipher blockchaining, CBC. And then we have cipher feedback, output feedback, and counter mode. So now we are going to study only this electronic codebook, cipher blockchaining, and also the counter mode. Okay. So first one is this electronic codebook mode. This is the simplest among all these five modes. Okay. So here, as we have discussed, it is going to use the block cipher mode of operation. So it is going to take the plain text in blocks. Okay. So it will handle one block at a time, and the since this is a very simplest method, here we are going to use the same key for all the blocks. Okay, we are going to use the same key for all the blocks. So each plain text block will go through the encryption process, and it will generate a cipher block. And so why this term code book is that, so it will be so you will have a list of ciphertext available for each of the each bit of plain text. Okay, so that is why it is called as an electronic code book. Similarly, decryption. So decryption process, again, what will you take? You will take the ciphertext block and apply that same key, and you'll be getting the plain text. So now this ECB method, since this is very simplest method, and we cannot ensure security much because we are going to use the same key every time. So what would be the problem is that you will be, for example, if you are using a message where some of the words are repeating. Okay, so for example, I'm just writing hmm, uh, come to Coimbatore tomorrow, and come and meet me at 11 o'clock. Okay, so now this, if this is the message, now this will be converted into blocks. And if suppose, if this word come, it repeats, and if it supposed to get into two different blocks, so for example P1 and some P8, or the blocks that contains this word. Okay, so what will happen, your ciphertext will also be the same, since you are going to give the same key to both the plain text blocks, and you will be receiving the same ciphertext. So this will help the cryptanalyst to guess somewhat, okay, what could be the message, or what could be the repeated words, because he would have several plain text ciphertext pairs he will be having. So he will be analyzing with that, and he'll be able to come out with that. So this will be ideal only for a short amount of data, short amount only for short amount of data, that this can be helpful. So you can see
Call
the
60.
all of you kindly unmute your mics. So you can see the ECB mode here. Now the plain text block, the given plain text is divided into blocks of some B bit size. Okay, so P1, P2, and so on up to Pn. Now all these plain text blocks are individually or separately encrypted using the key. Okay, using the same key, all these plain text blocks are encrypted, and so you are getting the ciphertexts as again blocks of the same length, C1, C2 up to Cn. Now the decryption process is also very simple. Again, the ciphertext is decrypted using the same key, where you will be getting the plain text blocks. Okay, so this process is very simple. Now, advantage is that, as we have seen, it is used for sending a few blocks of data. For example, this can be used for example, we in public key cryptography, we have seen that in your symmetric encryption, we see that both the sender and the receiver. For example, if Alice and Bob are communicating, they should have a common key in between them. Okay, so that encryption key may be sent to the other person using this kind of ECB method. Okay, so because the key would be of size, the total size of the key itself would be some 256 bit or something. Okay, so you can use this method to send the encryption key and so on. Okay, and but as we have seen, the message repetitions can be easily found in the ciphertext. So if you are using this method for sending a huge blocks of large number of blocks of data, and if there is some repetition, then easily it could be found in the ciphertext. Okay, so that would become a advantage for the cryptanalyst to analyze and see what kind of data he is sending. So these are some of the advantages and limitations. So to strengthen this method, we need to go for some other modes of operation. Okay, so what are the to improve the security? Okay, so what we require in other modes of operation. So the electronic code book we have seen, and it is a very simplest method, and it is not very secure for the large blocks of data. So how we can strengthen this, and uh, what are the properties we need to expect in the other modes of operation that we are going to discuss. So the first one is um, the overhead. Okay, the additional operations for the encryption and decryption operation when compared to uh, encrypting and decrypting in the ECB mode. So here it is very simple. In electronic codebook mode, it is very simple. We take the plain text block and encrypt with the key, and then we immediately get the ciphertext. So instead of that, we need to do some additional operations both in the encryption and decryption, so that the ciphertext that we are receiving, it would be more secure. Okay, so we need to have some additional operations both in the encryption as well as decryption. So that is what is desired in the other modes that we are going to discuss. And error recovery. So if there is a error in the ciphertext, that is, if some part of the ciphertext block is attacked by a person, and if it is changed, then that should be carried over only to the few plain text blocks that is following that. Okay, and not other things should be affected, so that you will be able to easily recover from the error. So that is another point. I hope you understand. So you have several ciphertexts available, right? Okay, C1, C2, C3, C4, and so on up to C10 you are having. Okay, so in for example in the block number C8. Okay, because what the hacker will be able to get is this ciphertext blocks. So if he is able to insert some error in this particular block, then this error should be carried over only to the remaining blocks. Okay, so that we need not worry about all the previous blocks, which we should be able to guarantee that all the previous blocks are not corrupted and it is safe. Only the blocks that from which it is getting affected, we need to take care of and rectify the error. Okay, so that error recovery would be better. And this is also the same thing, error propagation, the property that an error in the ith ciphertext is inherited by the ith and all subsequent plain text. So if there is some error that happens in a, so it is not the computational error but the transmission error. So here we say that some additional operations has to be done. So during that additional operations, as you transmit one ciphertext block to the other, the next process of operation. So if there is some error happens in the transmission, then it should affect only the subsequent blocks and not the previous ones. Okay, so this one has to be taken care of. And diffusion. So diffusion is something like the already we have discussed about the transposition techniques. So how this ciphertext, how this diffusion is reflected in the ciphertext. Okay, how far we are able to diffuse or transposition the plain text so that we'll get a better ciphertext. Uh, and security. So the ciphertext blocks should be such that it should not leak the information about the plain text blocks. So it should be secure enough, and cryptanalyst should not be able to grasp or guess what the plain text would be from the ciphertext. Okay, so these are some properties that are desired from the remaining modes that we are going to discuss. So the next mode that we are going to discuss is the cipher block chaining mode. So we can call this in short as CBC mode. So the first mode we have discussed is electronic code book, okay, ECB mode. And now the second thing is a cipher block chaining mode. So we have seen there are certain security deficiency present in ECB. Okay, so here in ECB, the same key is used for all the plain text blocks, and if the plain text is going to repeat somewhere, then you will be getting the same ciphertext. Okay, so to avoid this kind of thing, we are going to go for this cipher block chaining mode, where we are going to do some additional operations. Okay, if you look into this picture, you'll be able to understand. So here what we are going to do is the we have the plain text blocks. Okay, the message is divided into blocks of plain text, and each block is of same size. And here what we are going to do is every time the encryption happens, along with the key, okay, along with the key, we are going to encrypt this uh, uh, before encryption, the plain text is going to be XORed with the previous ciphertext. Okay, so now the second plain text block I'm showing here. So this plain text block, it is going to be XORed with the previous ciphertext. Okay, so what happened to the first one? For the first plain text block, we do not have the ciphertext. So instead of that, we will be having some initialization vector. Okay, this initialization vector, we can choose some value, and this value has to be transmitted to the receiver side also. So the receiver also should know this initialization vector, so that for decryption also this will be used. So now in the first phase, the plain text will be XORed with the initialization vector, and that result will be encrypted using the key, and you will get a ciphertext. And now this ciphertext will be XORed with the plain text, the next second block of plain text. So the result will be again encrypted with the key. So this will keep on going. So that is why it is called as a chaining method. You can see, okay, it is a chain of reactions or chain of operations happening. So each encryption process, it depends on the previous ciphertext. Okay, so that is why it is called as a the cipher blockchaining method. Okay, and so you can see here, initially the first one will be initially this ciphertext will be the initialization vector for the first plain text block. So we'll be first XOR the plain text and the so in the first phase it will be initialization vector, and in the remaining phases it will be the first C1, C2, C3 and go on, so on. Okay, so first we have to XOR that, and then using the key we need to encrypt it. So this cipher block chaining can be used for bulk data encryption as well as for authentication purpose. We can use this. So similarly, decryption. So how will you do the decryption? So we take the ciphertext. Okay, so the ciphertext will be taken, and this will be decrypted using the key first. Okay, this will be decrypted with the key first. So the result that you are getting after decryption, that you have to again XOR with the so for the first plain text block, we need to XOR it with the initialization vector. And then for the remaining ciphertext blocks, as we have already seen here, it should be the previous ciphertext. Okay, so second ciphertext block, it is decrypted using the key. So the result should be XORed with the previous ciphertext. So that you will be getting the plain text block. Okay, so this process repeats till the last ciphertext block, so that you will be getting all the plain text blocks. So this is what the cipher block chaining or CBC mode. So this is given how we need to do the decryption process also. So the only limitation of this is that we need first the initialization vector, and this initialization vector has to be communicated to the uh, other receiver side also. So here in this case, to transmit this initialization vector, we can use the ECB mode. Okay, so because ECB mode is very simple, as we have seen, it can be used for transmitting the very small blocks of data. So the initialization vector is we can choose some value, and that value can be transmitted using the electronic codebook method even, so that it will be this value will be encrypted and sent to the receiver side. Okay, so that we can do. So for all the general purpose block oriented transmission, this CBC method can be used, and it is helpful to authenticate the message also. And the third mode that we are going to discuss is the counter mode. Okay, so counter mode here, the difference is that here we are going to the whatever we can say, so the block, the there we have seen that first the plain text is encrypted And so first the plain text is XORed with the ciphertext, and then we encrypt it, right? So here we are going to use some counter value. Okay, so we are going to use a counter value. So like how we have chosen some initialization vector, here also we can choose some counter value. But the difference between the cipher block chaining and counter is that there we are using the previous ciphertext in the next round also. Okay, but here we are not going to do that. Here we are going to take some counter value, and this counter value is going to be encrypted with the key. Okay, we should remember we are not encrypting directly the plain text. Okay, we are not directly encrypting the plain text. Okay, we are going to encrypt the counter and the key. So this counter is some value we are going to choose. Okay, it may be a nonce value or something we are going to use. And after encryption we are going to XOR it with the plain text. Okay, so go through these diagrams very clearly and write it and study. So after encrypting this counter and key, the resultant value is going to be XORed with the plain text. Okay, so this is very important. So that gives you the ciphertext. So there is no connection between this and this. Okay, there is no chaining happens. This ciphertext is not going to be used there. Rather, what we are going to do is we have assumed some counter value right here. So that value is going to be incremented for every block. Okay. So counter plus one, counter plus 2, counter plus 3, and so on, and counter plus the n minus 1 value. So we are going to increment the counter values in each phase of for each block of plain text. So so for encrypting the second block of plain text, what we are doing, we are incrementing the counter value and encrypt it using the key, and that will be XORed with the plain text. Okay, so now this process happens for every single plain text block separately, and so you will be getting different ciphertexts from C1 to CN. So similarly, if you look into the decryption process, you see here again we take, because this counter value like the initialization vector, again this has to be transmitted to the receiver side. Okay, so if the both the sender and receiver or both the people communicating should know what this counter value is. Okay, so what happens here, the counter value, this first counter we have taken, that will be again, sorry, here it is given wrongly, decryption. Okay, so this is not encryption, this is decryption. Okay, it is given as encryption. So we are going to decrypt that, and the resultant value, it is going to be XORed with the ciphertext that we have received. Okay, so this counter should be known to both sender and the receiver. So we are going to decrypt it and again XOR with the ciphertext. Here we are XORing with the plain text to get the ciphertext. Here we are XORing with the ciphertext to get the plain text. Okay, so this is what the counter mode is about. And so now using this counter mode, you can do parallel encryptions. So in the previous case, in CBC mode, it is chaining method. So definitely you need to wait for the previous process to finish. So only when your first ciphertext is ready, you will be able to do the next you can encrypt the next block of plain text, because you require this C1. Okay, whereas here it is not so. Okay, so here you need not depend on the previous ciphertext or previous values. You can do it, you can do all these because once the counter value is known, you can simply increment this counter value for every block of plain text, and you can parallelly do all these encryptions. Okay, so that is one advantage. You can do parallel encryptions either in the hardware or in software, and to improve the speed of doing that and sending the message, it will be good. And the security is also uh, better than other modes. But here it will not reuse the same key and the counter value. Okay, so the counter value should be a nonce value. So once for one process, if it is for one message you are using this counter value, it should not be used for the next message also. Okay, so for only one communication this counter can be used. For doing the other communication, for sending the next message, you need to have another separate counter value. Okay, so that is important. So again, this is also used for all block oriented transmission, and for high speed requirements wherever it is necessary, we can use this. Okay, so do you have any questions on this? If you understand this concept, you can please reply in the chat box whether you understand this concept. Do you need any clarification? Okay, few of you are replying. Thank you.